Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. We are now at question 2, CXC CSEC, June 2013 exam video solution. And the first part here wants us to factorize completely. We are doing part A of question 2. And the first part wants us to factorize completely this expression. Now I see two terms with a negative sign. So since I'm doing factorization, I'm thinking the difference of two squares. But initially, I'm not seeing the difference of two squares, but I'm seeing common factors in these two terms. So in terms of the numbers, the numerals, the common factor is 2. And in terms of the variable, which is x, the common factor is x. So I want to factorize those first. So firstly, I factorize the numbers, and that is 2. And the common factor in the variable x is just x, because x can be divided from here and x also can be divided from here. So 2x is the highest common factor of these two terms. And to proceed now with the factorization, we divide this term by 2x. The result is x squared, and we can show that. And to factorize 2x out of this term, we simply divide this term by the 2x. And when we divide the 8 by the 2, that's 4. And then the x divided by the x in the 2x here leaves us with just 4, and that's a negative 4. And so my first line of factorization is here, and I'm still thinking about the difference of two squares. So I examine the terms in the bracket, and here we now have the difference of two squares, because this is x squared and this 4 can be written as 2 squared. So this expression inside the bracket can be written as x squared minus 2 squared. And so the difference of two squares was hidden inside here. And so this term reduces to this. Now let's look at the rule for the difference of two squares. The difference of two squares, a squared minus b squared, will be equal to the product of the difference of the two numbers, the a and the b, and the sum of the two numbers, a and b. So that's a rule for the difference of two squares. And so if we apply this rule to the term in the bracket, this expression reduces to 2x remains outside here, and then x squared minus 2 squared is x minus 2 multiplied by x plus 2. And so this expression reduces to these three factors: 2x, x minus 2, and x plus 2. So those are our three factors. So we have factorized that expression completely. So that's the answer for part 1 of question 2a. Let's go down to part 2. Now part 2 gives us this quadratic expression to factorize, and so we can follow the standard process of factorizing a quadratic expression, and we'll go through the process here. And again, the process involves splitting this middle term, the negative 5x, into two terms, so we form 4 terms. We want to convert this 3 terms quadratic expression into 4 terms so we can factorize by parts. And so we need to split this negative 5x into 2 terms. And to split this negative 5x so we can successfully form 4 terms that can be factorized by parts, we firstly multiply the two end coefficients in this quadratic expression. So we multiply this 3 by negative 2. We must remember to carry the sign of the constant term, the negative 2 here. So we're multiplying the 3 by negative 2, and that's negative 6. Then we are looking for factors of negative 6 that add to the coefficient of the middle term, which is negative 5. So let's show that. So this means that we are looking for factors of negative 6 that add to negative 5. And the first two factors of negative 6 would be 1 and negative 6. And I must point out here now that because we want the sum of the factors of negative 6 to be negative 5, the larger of the two factors of negative 6 must be the negative 1. Factors of negative 6, one factor must be positive and one must be negative. And because we want the sum of those two factors to also be negative, we must give the larger of the two factors the negative sign. And so the first two factors to try would be 1 and negative 6. 1 and negative 6 are factors of negative 6. And when we add 1 and negative 6, the result is negative 5. So we have already found the result. So yes, we have found what we are looking for. Factors of negative 6 are 1 and negative 6, such that when you add them, 1 and negative 6, the result is negative 5. But let's say we had tried 2 and negative 3. 2 and negative 3 are also factors of negative 6. But the problem is that when you add 2 and negative 3, the result is negative 1, which is not negative 5. We want factors that add to negative 5, and therefore we could not use 2 and negative 3 as the factors of negative 6 we are looking for. And so these are the two factors we want, 1 and negative 6. So we are going to split this negative 5x into 1x minus 6x, right? This is it. The factors we are looking for, factors of negative 6 that add to negative 5, are 1 and negative 6. And therefore this negative 5x, this middle term, will split into 1x minus 6x. The 3x squared term comes back here. The negative 2 term comes back here. And then the negative 5x, we split that negative 5x into 1x minus 6x, using the two factors that we found that add to negative 5, because 1x minus 6x is still equal to negative 5x. And now we have four terms. We can proceed by factorizing by parts. So we look for a common factor in the first two terms. In this case, that common factor is just x. And so we factorize the first two terms by taking out the highest common factor, which is x. And when we divide the 3x squared term here by x, the result is 3x. And 1x divided by x leaves us with this one here. So that's it. We have factorized the first two terms. And what I always tell my students, to ensure that the factorization of this expression proceeds smoothly, we place the term inside the bracket here. We place it here first, because 3x plus 1 must be a factor of these two terms. And then we examine this 3x here as compared to this negative 6x here. What would we need to factorize out of negative 6x to have 3x remaining inside here? That factor would have to be negative 2. Or simply we can say negative 6x divided by 3x is negative 2. And so the factor outside here must be negative 2. And so the key step, as I said, is to place the 3x plus 1 term here first, and then deduce what we had to factorize out of negative 6x, such that we have 3x here, and that result is negative 2. And what I normally do is check this factorization by expanding this again to see if the result is this. And so negative 2 multiplied by 3x is negative 6x, which is correct. And negative 2 multiplied by positive 1 is negative 2. And so we know that the factorization is correct. So what we have now is 3x plus 1 as a common factor. And therefore, x multiplied by this minus 2 multiplied by this is equal to x minus 2 multiplied by this. And so that's our factorization of that quadratic expression completed. That's a complete factorization. These are the two linear factors for this quadratic expression. And so that's the end of part 2 of question 2a. Okay, so let's move down now to 2b. Now 2b is telling us to make c the subject of this equation. So we basically want to transpose this equation to make c the subject. And to do that, we need to get rid of this 32 from this side, and also get rid of this fraction, this 9 divided by 5 from this side, such that c remains as the subject. So what we can do as a first step is get rid of this 32. And to get rid of this plus 32, we would subtract 32 from both sides. So let's show that. We would have to subtract 32 from both sides. And this minus 32 will eliminate this 32 on this side
and then this negative 32 will remain on this side. So on this side we end up with f minus 32, right? So let's go ahead and show the result of that, and this is it. The 32 is removed from the right hand side, and we now have f minus 32 on this side. Another shortcut way of doing this transposition is to say we take this positive 32 over onto this side and subtract it. So that's a quick way of doing this transposition. Take the positive 32 over onto this side and change the sign to negative 32. Now we have 9 divided by 5 multiplied by c, and we want to make c the subject, so we need to leave c alone as a subject. So we have to get rid of this 9 divided by 5 as a fraction. So to eliminate this fraction, we simply multiply by its reciprocal, and the reciprocal of 9 over 5 is 5 divided by 9. So to eliminate this 9 divided by 5, we multiply both sides by 5 divided by 9. So let's show that. And this is it. We are multiplying this side of the equation by 5 divided by 9, and we're also multiplying this side of the equation by 5 divided by 9. And on this side, this 5 will cancel this 5, and this 9 will cancel this 9. And this 5 over 9 on this side will remain multiplying by this in the bracket. So let's show what would happen here. This 5 would cancel this 5, this 9 would cancel this 9, and we'll be left with c multiplied by 1, which is c on this side of the equation. So let's show that. This reduces to c being equal to 5 divided by 9 into f minus 32. The shortcut way again of going from this expression to this expression is to say we multiply the 5 up here and we divide the 9 down here. So that's a shortcut way of going from this expression to this expression. Multiply by the 5 across here, cross multiply the 5, and cross divide the 9, and we will end up with this expression on this side anyway, and we have c as a subject, and so we can write it as c as a subject. C is equal to 5 divided by 9, that's here, into f minus 32, and that's it. We have made c the subject, and that's the answer for part 1 of question 2b. Let's move down now to part 2. Now part 2 is asking us to find c for which f is equal to 113. So we already have the expression where c is a subject, and to find the value of c for which f is 113, we simply need to substitute 113 for this f, and let's show that calculation. So if f is 113, then c is 5 divided by 9 into 113 minus 32. And we proceed by calculating the term in the bracket here first, and that reduces to 81. 113 minus 32 is 81, and then this 81 divided by 9 here leaves us with 9. That's it. 9 into 81 is 9, and 9 into 9 here is 1. And so the result here is 5 multiplied by 9 divided by 1. 5 multiplied by 9 is 45. 45 divided by 1 is 45. And so c is 45. And so c is 45 when f is 113. And that's the answer for part 2 of question 2b. Let's move down now to part c of question 2. Now part c tells us that 500 tickets are sold to a concert, and x of the tickets, x of the 500 tickets are sold at $6 each, and the remaining tickets, the remaining of the 500 tickets are sold at $10 each. So of the 500 tickets, x of them are sold at $6 each, and the remainder are sold at $10 each. And the first question is asking us for the number of tickets sold at $10 each, and simply that would be 500 minus x, because x of the 500 tickets are sold at $6 each, the remainder of the tickets are sold at $10 each, and the remainder of the tickets would be the 500 total tickets minus the x tickets that are sold at $6 each. And so the number of tickets sold at $10 each is simply 500 minus x. That's the number of tickets sold for $10 each. Okay, so that's the answer for part 1. Now part B here is asking for the total collected, an expression for the total collected for the 500 tickets. Now we have X tickets at $6 each, and we now have 500 minus X tickets at $10 each. So the amount collected for the $6 tickets would be 6 multiplied by X, and the amount collected for the $10 tickets would be 500 minus X multiplied by 10. So let's show that calculation. And this is it. The amount collected for the $6 tickets would be $6 multiplied by X because there are X of those tickets. And then the amount collected for the $10 tickets would be 500 minus X multiplied by 10 because the number of tickets sold for $10 would be 500 minus X. And so this represents the amount or the total collected for the 500 tickets. And when we do this calculation to reduce it to a simple term, we have 6x dollars, the dollar sign outside. So we have 6x here. 10 multiplied by 500 is 5,000 here. And then 10 multiplied by x is 10x here. We're subtracting that. So it's 10 multiplied by minus x is minus 10x. So that's 5,000. And then we have 6x minus 10x. 6x minus 10x is minus 4x, and so the expression inside the bracket here reduces to 5,000 minus 4x dollars, and that's a total. That's an expression for the total collected for the 500 tickets. 5,000 minus 4x dollars. That's a total collected for the 500 tickets. Let's move down to part 2. Now in part 2, we are told that the total amount of money collected for the 500 tickets is $4,108. Remember that this expression represents the total collected for the 500 tickets, and we are now told that the actual amount collected for the 500 tickets is this amount, $4,108. So it means that this expression here is equal to this $4,108. And we can proceed to show that the 5,000 minus 4x is therefore equal to 4,108, and part 2 wants us to calculate x, the total number of $6 tickets sold. That's what part 2 is asking us. So to find x, we simply solve this equation. We calculate the value of x from this equation, and this is it. The number of $6 tickets sold, which is equal to x, is calculated from this expression by making x the subject, and we can show that in one step. X will be equal to 4,108 minus 5,000 divided by negative 4. And to explain that, we subtract the 5,000 first and end up with this expression on the numerator, and then we divide by the minus 4 here, and so we end up with x being equal to 4,108, that this expression, minus this 5,000 on this side, and then divide by this negative 4. That will leave x as a subject, and this expression on the numerator reduces to negative 892. 4,108 minus 5,000 is equal to negative 892. This negative will cancel this negative here, and then the 892 divided by 4 will be equal to 223. It means that x is equal to 223, and remember, x is a number of $6 tickets sold, and so that's the answer for part 2 of this question 2C. Number of $6 tickets is equal to 223, and so that's the answer for this part of the question, and that's the end of question 2, and we'll do question 3 in our next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.